Myself, Dr. Sourav Debnath. The subject is utilization of electric power. The third module of this subject is electric heating. What do you mean by electric heating? Electric heating is extensively used both for domestic and industrial applications. Domestic applications include room heater, number 2 emulsion heater for water heating, number 3 hot plate for cooking, number 4 electric kettles, number 5 electric irons, number 6 popcorn plate, number 7 electric oven for bakeries, and number 8 electric toaster. And industrial applications include number 1 melting of metals, number 2 heat treatment of metal like annealing, tempering, soldering, brazing, number 3 moldering of glass, number 4 breaking of insulator, number 5 enameling of copper wires. These are the various applications of electrical heating for which are used for both domestic and industrial purpose. Next is advantage of electrical heating. First advantage is cleanliness. Electrical heating does not produce any ash and it is clean system. Number 2, no pollution as no flue gases are developed, so no pollution of the environment. Number 3, it is economical. Number 4, easy of control. Electrical system can easily controlled compared to mechanical system, and it is precise control of 5 degree centigrade temperature. You can increase the temperature by 5 degree or decrease the temperature by 5 degree smoothly. Specific heating requirement, special heating requirement, high efficiency electrical system has highly efficient, better working condition, heating of bad conductor is possible, safety and lower attention and maintenance cost. These are the various advantages of electrical heating. Heating can be done in different ways: conduction, convection, and radiation process. In the radiation process, dissipated heat is equal to 5.72 EK, where E is the emissivity and K is the radiating efficiency, into T1 divided by 100 to the power 4 minus T2 divided by 100 to the power 4. It is expressed in watt per meter squared. Different type of heating process. Electric heating is broadly classified into two. One is power frequency heating, another one is high frequency heating. Power frequency heating is divided into two subcategories. First one is resistance heating, another one is arc heating. Resistance heating is divided into both two: direct resistance heating, indirect resistance heating. Arc heating is also divided into direct arc heating and indirect arc heating. And high frequency heating is divided into three: induction heating, which is subdivided: direct cold type induction heating, coldless type induction heating, dielectric heating, and infrared heating. Now, direct resistance heating. In the direct resistance heating, the charge particle is placed here. This is the charge particle. And electrode is poured into this charge particle, and supply is given through the electrode. And direct current is passing through the charge particle from one electrode to another electrode. And as a result, the charge particle is heated up. For safety related issue, we are use high resistance powder, because if there is the potential after potential breakdown, there is the short circuit path. So the safety related issue, we are using high resistance powder above the charge particle. only for safety related issue. And the another utilization of this high resistance powder is heat developed into this charge particle cannot be dissipated out. Okay, that's why almost uniform heating can be done with the direct resistance heating. Next one is indirect resistance heating. In the indirect resistance heating, charge particles are allowed to heat it up indirectly. That means that here is heating element which is encapsulated into this glass tube, and the charge particle is installed here also, and all of the system is protected by this insulation. Okay, after after passing the electricity into this wire, it is heated up, and this heat is conveyed to this charge particle, and the charge particle will be more uniformly heating compared to direct resistance heating. Requirement of good heating element. Good heating element should have some properties, that is, it should have high specific resistance. When specific resistance of material of wire is high, only short length of it will be required for a particular resistance and hence heat, or for the same length of the wire and the current, heat produced will be more. Number two, high melting temperature. The heating element should have high melting temperature. Number three, low temperature coefficient of resistance. Number four, high oxidizing temperature. High oxidizing temperature ensures longer life of the material heating element. Number five, positive temperature coefficient of resistance. That means that increase the with increase the resistance, with temperature the resistance will be increased, and more temperature will be developed. It should be ductile, and it must have such mechanical strength. Next one is design of heating element. We have seen that Stephen's law says that heat radiated from the system is H is equal to 5.72 EK T1 divided by 100 to the power 4 minus T2 divided by 100 to the power 4. It is proved. Next one is power. Power is equal to voltage square by resistance. If it is the cylindrical type wire, R is equal to pi by 4 d square, and simplified it and equate it. After that you have get the equation, that is the P is equal to pi dl H. Putting all of this, you have get this formula here. If the wire is not cylindrical ribbon type, then the wire area is WT area is length into breadth into height. In that case, the formula becomes T by L square is equal to 2 rho H divided by V square. Thank you. We should continue in next slide for the remaining part. In next video, you should follow.